If this line contained this point, so this should satisfy the equation of the line. Let's put it here. We have Q is equal to 3P plus 1, or we can say Q minus 3P minus 1 is equal to 0. Q minus 3P minus 1 is equal to 0. If we negate it, we can also say that 3P minus Q plus 1 is equal to 0. In this case, we have 3P plus 1 minus Q is equal to 0. This one is equal to this into P plus 7 minus 4Q is equal to 0. So it's possible that either this is equal to 0 and this is not equal to 0, or it is possible that this is not equal to 0 and this is equal to 0. It is also possible that both are equal to 0. Okay, so see, for this being equal to 0, a check mark is also possible, a cross mark is also possible. Yes and no, both are possible. So statement 1 is not sufficient. Look at statement 2. Q minus 3P minus 1 is equal to 0. So once again, maybe if this is equal to 0, the product is equal to 0. So maybe this is 0 and this is not, or this is not and this is, or both are. So once again, a cross mark and a check mark, both are possible. So this is not sufficient. On combining, this is where the trick lies. A lot of students will think that C is the correct answer, though it is not, because it is possible. One possibility is that, of course, this is equal to 0 in each case, and that is why we are getting the product as 0. But other very interesting possibility is that maybe P plus 7 minus 4Q is equal to 0 and 5P plus 2 minus Q is equal to 0. Each of them is equal to 0, and if you solve them, you will of course get a value of P and Q, which would not satisfy Q minus 3P minus 1 is equal to 0, because the coefficients are not the same with either of the two equations, for this one. So maybe it is the case that these two are equal to 0 and this is not equal to 0. Because of that case, even on combining, we cannot be sure that it is 3P plus 1 minus Q, because of which both the statements are sufficient. So even on combining, we cannot be sure. It's a very good question. The right answer is option E.